All right, guy. Oh, what time is it? What time is it? All right, guy people. I have just one announcement, and the announcement is on Friday. We have test number 3. My online class is going to be on Monday, but for us, I think Friday is fine. If something goes wrong along the path and we're a little behind, I might push it back to Friday. But I think we should be fine. Um, we should be fine for Friday. I think we should be fine for Friday. So my cross fingers is to finish the entire because remember this test is only on 3 sections, just 5.1, 5.2, and 5.3. And so my goal is to hopefully finish everything because we just have these two to do. And this one is not long at all to finish off. But before we do that right here, we have to first remember we are looking at what is called your binomial distribution. Yes? Your binomial distribution is made up of 4 key points. And again, about 3 or 4 questions on the test is just going to be about these points. Okay? Don't read the board. It's not up there. Pretend like it's not up there. What are the 4 things that make a binomial distribution? You have to have fixed number of trials. That's right. Before you start, you have to know how many times whatever you're doing is going to happen. IDD, that's right. Independent and identical. Every single event must be exactly the same thing that's happening, but they also must be independent. One does not affect the other. All right, 2 more. There are only 2 possible outcomes. One of them we will label a success, what we want to happen, and the other one is going to be labeled a failure, what we don't want to happen. All right, last one. The probability of a success is known and fixed. We know what's the probability of us getting a success. Question there. Flipping a coin does count as a binomial distribution if you know how many times you're going to flip the coin before you get started. All right? So if you're playing a game, and in this game right here, you're going to flip a coin 7 times, and the 2 people are playing against each other. One chooses heads, and one chooses tails. If I'm the heads person, right, then I am the what's what I'm looking for? A success if it flips and gets heads. Yes, and the winner of this game is whoever gets more. Yes, and so you can ask what's the probability that I get 4 heads in this game? Questions there. The last thing we ended on was using technology. Don't you guys love technology? Our friend John had damaged his credit card. Oh no. You ever seen that right here? Sometimes the credit card's got that little grease on there. When you plug it in there, it doesn't work. Yeah. Well, his car is damaged, and so there's only an 80% chance that it will be successful. John is going to use his credit card 8 times today. So then we have these 3 statements right here. First things first is I am a definition of what it means to be a success, or what is it I am trying to accomplish, and what is it I am looking at. In this case right here, X should be, I'm missing the word number right here, the number of successful swipes of the credit card. So I am missing the word number on here. Uh-oh. Let's fix that. The number of successful swipes of the credit card. Therefore, X, this little tilde right here, means follows, and then this right here is short for binomial distribution. Literally, we'll show you some other distributions in statistics. There's a uniform distribution, there's a normal distribution, there's the Poisson distribution. There are lots and lots of ways, rules that different things in life follow, yes? Right? But in this example right here, X follows a binomial distribution, and they always give you 2 numbers, n and p. N is the The number of trials. Again, we have to know how many times the event happens before we get started, yes? And P is going to be the probability of a success. Once they give us P, they also give us Q. What's the probability of a failure? It's going to be 20%, 1 minus P, yes? So one of the nice things about a binomial, because there are only two possibilities, you have both. If I give you one, I am giving you both of them. Yes? Question there. And then the last statement right here is me asking a question. What is the probability that the number of successful swipes of a credit card is exactly 6? So what I'm saying right here is not 6 or more, or not maybe 6, exactly 6. Yes? And then we got this answer right here. Let us remind ourselves how we got this answer. Go ahead and open up SALT on your handy dandy computers. We're going to need SALT. Where is my, did I close SALT? Did I close SALT? I guess I did, huh? So Google, oh, gosh, I should be using Chrome actually. SALT works better in Chrome. For some reason, some of the capabilities don't show up unless you're in Chrome. And so it's just a better idea to just go ahead and just, oh, there it is right there. So just go ahead and use SALT. Let me reset. So when you pull up SALT, this is what you should see right here. And the key thing right here is we're going to this section right here, distribution calculators. All right. And then you click on it right here. And then normally the first distribution they have is something called the normal distribution. This is actually the next distribution we're going to study. But for now, you click the drop-down arrow and you want the binomial distribution. Here are three other distributions: the T distribution, the F distribution, and the chi-square distribution. But like I tell you, there are actually a lot of distributions out there. Uniform distribution, Poisson distribution, the geometric distribution. No, doesn't it just get you ready to go? Binomial distribution right here. And then first things first, you'll always see two squares because that's all it needs. Yes, number of trials and the probability of success. For example, I'm flipping a coin 10 times. Then this is the two numbers that I will need. Yes? And then the last thing down here, right here, is the question that I'm trying to answer. So the question we were answering was, he was swiping his card 8 times. The probability of a success was 0.8 or 80%. And then very importantly over here, we have to make a selection of what's called a left tail, right tail, both tails, between, and equal. All right. Right now, you see how it has selected left tail? Left tail means less than. And so if you look over here, you see X is less than. All right. Another way of saying this right here, let me put a larger number in here. Let me put in a 5 for us so you can just see. Put a 5 right here, less than right here, less than 5. Notice right here, 5, 6, 7, 5, 6, 7, 5, 4, 3, 2, 1, 0 are shaded. The 1 and 0 are so small, that's why they're off there, but they're actually part of the distribution. It goes down to 0. And you can see these are shaded on the left side. All right. If I switch it to a right tail right here, it will shade on the right side, greater than or equal to 5. So it's going 5 or higher. All right. If I click on between, for example, it will show now 2 boxes because between means between 2 values, right? So between 5 and 6. So in other words, greater than 5 and less than 6. And so you see it shades right here in between. Questions? But the one we need is equal. For our question is, what's the probability that he has 6 successful swipes? And that probability is 0.2936. Question. Let's try using some of those other questions that they have right here. So how about this question right here? What's the probability of at least 5? What's the probability of at least 5 swipes? What's the probability of at least 5 what? The probability of at least 5 means 5 or more, correct? Yes? And so then I will go into my handy dandy machine right here. Am I going to select left tail or am I going to select right tail? I'm going to select right tail because I want 5 or more. And then what comes in this box right here? 5, yes? Because you wanted 5 or more. And then I can go over here to the picture for confirmation. Notice 5, 6, 7, and 8 are all shaded. And then here's the answer right here, 0.94372. There is a second way to get this answer. 5 or more means either 5, 6, 7, or 8, yes? And so the other way to the answer is get the answer for 5 by itself, get the answer for 6 by itself, get the answer for 7 by itself, get the answer for 8 by itself, and then add them all up. Yes? But basically just doing it for us. See how they're all shaded? So they're all being added together to give us this answer right. Question there. So if I go back over here into my notes, you'll see right here, for at least 5, you can figure out the answer for 5, find the answer for 6, find the answer for 7, find the answer for 8, and then add them up. And that will give you the answer for at least 5. Question there. All right, go ahead for me, please. Where is it? Go ahead for me, please. Find the answer for no more than 6. Go ahead and find the answer for no more than 6. Once you have the answer, raise your hand so I can see where I am in terms of weighting. Again, use salt. Go ahead and find the answer for no more than 6. Once you have an answer, just raise your hand for a second so I can see where see how long I need to wait. You don't have to leave your hand up, just put it up in the net. That's good enough for me. Anyone not sure what to do? All right, 10 seconds, people. All right, am I going to use a left tail test or a right tail test for this one right here? I'm going to use a left tail test because no more than 6 means 6 or less, yes? And so I'll come up over here. I will switch this thing to a left tail test and I'll put a number 6 in right here. And then there you go. Does that answer get 4.9668? Question. Question. Hello. Not you, not you. Everybody. Everybody. All right, let's try again. What's the probability of no more than 5? What's that going to be? What's from no more than 5? What did I say? No more than 5? Yes, yes. So don't do this right here. Let me put an N right here. No more than 5. Let's do that right here. No more than 5. Let's do that one right here. Oh, just yes, raise your hand once you believe you have the answer. All right. When we say no more than 5, what numbers are we talking about? 0, 1, 2, 3, 4, and 5, yes? Right? So in other words, 5 or less, yes? And so this is going to be a left tail or a right tail test? Going to be a left tail test. And so right here, left tail test right here, 5, and the answer is 20.20, 0.20308. Questions there? All right. One of the things that we like to point out in this section is that English is very important, right? If you look at what I had before I erased all of this right here, if I said more than 5, or I say at least 5, you will not get the same answer, yes? Because more than 5 means I am not including 5, yes? Right? But if I say at least 5, then I am including 5. So one of them will be 6, 7, and 8, while the other one will be 5, 6, 7, and 8. Yes? And so you have to pay attention to the language that is being said. Questions there? All right. Let me ask you to do 2 more right here. Find the probability of between 2 successes and 7 successes, and then find the probability of at least 6 or no more than 3. Try these 2. Find the probability between 2 and 7 swipes are successful, and find the probability of at least 6 being successful, or no more than 3 being successful. You shouldn't be using 8 and 0.8 because there are 8 swipes of the card, and the probability of success is 0.8. Again, yes, those numbers are very. So Google Google SAL website. Yeah, I normally bookmark the page for solve. Also, if there is a question that you can solve, click on the link in the product, and that will load all the numbers for you. So you can call yourself. Again, Google SALT and website, and that will give you what you need. Yeah. When you want to go to it, go there, so you can give it a scope. And then click on distribution calculators. And then in the first top left, click on binomial distribution. So changing a normal distribution to binomial distribution. And I'll pull it up. Put in 8 for n and put in 0.8 for p. Anybody else need help into the website? But if you want to, while you wait, you can play around. You can put in n equals 12. You can put in p equals 0.2. If you want to, you can play around. If it's nothing, those need to the website. And if you have any other questions, you can play around. If you look at the answer, most likely all right. Just trying to make sure everyone is on the same page. Oh, I know the answer. I missed stuff. Oh, I'll show you. Yeah, while you wait, you can play around with this. You can plug maybe n equals 100. All right. Anyone been questions about it? I will move on to our next question. The salt calculator, the reason why I suggest using it is that when there's a person that uses salt, if you're familiar with it, helps. But in theory, if you want to use a different calculator, please let me know. And then once I approve it, and then look at it and see. All right, are we ready? All right, so between 2 and 7. So I'm going to start at 2 and I'm going to end at 7. So I click on, very important right here, between. And then I just put down here 2. And I put over here 7. Notice right here that it shades the columns between 2 and 7. And answer right here, 0.83214. Questions? The other one was a both tails question. We're looking at the outsides, yes? And it was at least how much? 6. So therefore the second box is going to be 6. And then no more than 3, I think it was. And so right here, you see it shades this side right here and shades this side right here. And so that gives us this answer right here. I have a question for you. What would be the answer if with these two right here, I added in the values for these two blue box that are blue areas that are not shading? If I add in 0.0458 and I added in 0.01468, if I added these two to this right here, what would the answer be? The answer would be, indeed, the answer would be 1, because this is a distribution. And one of the requirements for a distribution is that if you add up the entire set, the answer is always 1. Yes? And so that means that there are always 2 ways to get an answer. I could have simply added these 2 values together and subtract 1. Yeah? There are always 2 ways to get the answer. You can either add up all the golden blocks or add up all the blue ones and subtract 1. Either way will get you to your answer. Questions there? All right, so the last thing I got to show you, which is unfortunately only in passing, you have to take a different class, STA 4443, I believe it is. But whenever we say X follows a binomial distribution, this is the formula that SALT is using to get your answer. What you need to do is you need to find the probability of a success and a probability of a failure. Yes? How many successes am I going to have? Let's say I'm going to have 5 successes. Yes? Then I raise P to the 5 because I'm going to have 5 of them. Yes? Then the rest are going to be failures, correct? Right? So then that's going to be Q raised to the 3rd power right here. And then you have to just multiply by the number of combinations that this can occur at, and that will give you the probability of a success. Yes? So if I have 5 successes, I have to have 3 failures, yeah? And so I will have number of successes to the 5th power, number of failures to the 3rd power, and then I just multiply by the number of combinations or the number of possible ways that can happen. And that will give me the probability of a success. Questions there? Do you need to memorize this formula? Try to remember. I know there's one homework question that reuses the formula. I can't remember if it's on the test or not. Let's just assume it's on the test. But really and truly, we don't expect you to use this formula. We expect you just doing stuff. All right? If you take the other stats class, then they will force you to use it. What? They're looking at me weird. Y'all don't think that is a lovely formula? All right, so that takes us to our last section, 5.3 on the test. All right. In this section right here, we'll be looking at how to find the mean and how to find the standard deviation for a binomial distribution. First, I just want to remind you that we use the letter mu for the mean, or we use the words expected value. Those 2 things mean the same thing. And we use sigma for standard deviation. All right, that's just want to remind you of this fact right here. And to find the mean for a binomial distribution, it's a very simple process. To find the mean for a binomial distribution, you just need to multiply n times p, the number of times that you're going to have the activity times the probability of a success. That gives you your answer. Remember how a while ago we were talking about the credit cards, right? Are we having 80% chance of them being successful? Yes? Let's say I swipe my credit card 100 times. Yes? What's 100 multiplied by a 0.8? 80, correct? Doesn't that kind of sound like exactly the average amount of swipes you will have? If there's an 80% chance of it happening, you did 100 times, the average is going to be 80 of them. It will work 80 of them, yes? And so it turns out to find the mean, it's just NP. N times P, and that gives us the probability of the average, the mean, the expected value. Questions there?
What is each letter stand for?
N is the number of trials. P is the probability of a success.
Okay.
Oh, here it is. Here it is right here. The standard deviation, actually, before I give you the standard deviation, let me give you the variance. They should give you the variance. I don't know why they don't give you the variance. VAR. The variance, which is going to be sigma squared, is going to be NPQ. One of my favorite things when I learned this formula, it just sounded like the best thing in the whole wide world. NPQ. That doesn't sound like, doesn't like have a great ring to it. NPQ. No? Really? It just stuck in my head. I heard it once. I just said it all day, the whole day. I say NPQ. No? NPQ is the variance. Therefore, what's going to be the standard deviation? Therefore, what's going to be the standard deviation? The square root of NPQ. See, doesn't that just roll up down? The standard deviation of NPQ. And that right here is our variance right here. Our variance right here is square root of NPQ. Everybody remember what Q stands for? Probability of a failure. Yes? Or 1 minus P. So if P is 80% or 0.8, Q is 20% or 0.2. Questions there? That's literally the entire of this section. Eh? So the variance sigma squared is this, and right here is NPQ. All right, let's take this for a spin. But before I do that, any questions? Please and quiet. NPQ. Ah, cool. Cool. Can I say NPQ one more time, please? Please. No. Fine. I won't say NPQ anymore. A waiter at the Green Spot restaurant has learned from a long experience that the probability that a lone diner will serve a tip is 0.7 or 70%. During 1 hour, the waiter serves 6 people who are dining by themselves. Find the mean and the standard deviation for the distribution. To find the mean, I will need to simply multiply these two things together. So 6 multiplied by 0.7 gives us a mean of a 0.42. Questions, therefore, on the mean. So this means that on average, 4.2 individuals will leave a tip. It doesn't say about how much the tip is, right? Because remember, X is the number of people who will leave a tip out of those 6 people in that hour. Yes? And so it means most of the time he'll get 4 tips, and then every once in a while he'll get 5 tips, right? Between 4 and 5. There isn't 4.2 people. Yes, the way we interpret this right here is most of the time he will get 4 tips, and every once in a while he'll get 5 tips. Of course, he may get 3, he may get 6, right? But most of the time it's going to be around 4. That's your average. Questions there? On a really bad day, you get 0 tips, but we ain't wishing that on nobody, yes? Yes. All right. How do you find the standard deviation? You first find the variance, which is 6 times 0.7 times 0.3, and then you take the square root of that. Okay. And so the variance, square root of NPQ, if P is 0.7, then Q is 0.3. And then just multiply those together and then take the square root. And that gives us our variance, our standard deviation of 1.12. On average, 1 point higher, 1 point lower. Most of the times you get around 5 or 3. You won't see very often 2 or 1 people not giving a tip. You won't see very often 6 people giving a tip, right? The numbers will be about 1 point off from 4. Questions there? Comments? Concerns? Hopes and dreams? Cool. All right. So, literally, that's the end of the section. There's just this one type of problem that gives students issues. And so we'll look at a few of those right here. But to solve them, you gotta solve them in SALT. But literally, that's the entirety of 5.3. Just multiply either 2 numbers together or 3 numbers and take the square root. All right, quarter problems. Quarters occur. Quarters occur in aspects of everyday life. That means right here, there's a certain threshold or a certain amount that we're trying to reach. An example right here is again, we don't need it. All of this is extraneous. Let's just look at an example. They decided to teach it the hard way first. Let's just teach it the easy way first. All right, suppose you can buy some bonds at a very big discount. Suppose you consider only companies that are 35% estimated risk to default. So first things first, anybody know what a bond is? Anyone knows what a bond is? All right, so a bond, company A wants to raise money and they want to borrow money. That process is called issuing bonds. So let's say the company wants to borrow $1,000. I would give them $1,000 and they'll give me a piece of paper. That piece of paper is an IOU. Yes, that IOU is called a bond. All right. So literally it is, hey, I'm going to pay you back your money. And normally comes at a certain percentage, say 5%. So I'm going to pay you back your money plus 5%. Yes? Called interest. Yes. Right? That's what a bond is. Now the thing is this, the value of a bond is based upon how successful the company is. If a company is not very successful, then the value of the bond will go down. Yes? Yes? They say they're going to pay you back your $1,000 at the end of the year, but what happens if they're not around? Yeah. And so for those kind of things right here, even though the bond has $1,000 face value, you can get it at least as low as $650, 35% off. Because that company has a higher chance of defaulting on the loan. Okay? Okay? And so that's what they're talking about right here, where 35% of risk of default, 65% of chance you get paid, but there's a 35% chance that you won't get paid. That's actually a huge amount. And so because of that, they will give you a huge discount on that bond. That one might trade at 50% of its value. Literally, you give them $500, and at the end, they pay you back $1,000 plus interest. Or get nothing. Anyway, your financial investment goal requires 4 bonds to be good in the sense that they will not default, right? So in other words, you pay them that $500 and you get your $1,000 plus at the end. Other bonds in your investment group can default without harming, without harming your investment plan. Suppose you want to be 95% certain of meeting your goal, i.e. your quarter, of at least 4 bonds being good. How many bonds should you buy to meet this goal? So, how many gold bonds do you want to be good? That means you have to buy at least 4 bonds, correct? Yes? But because there is a only a 65% chance that the bond will work, do you believe all four of those bonds will make sense? Just buy four bonds, and you at the end you expect to have all four of them being good? No. So in other words, you need to buy more than four bonds, yes? Every time you add a bond in, the probability will go up. Yes? What they want to know is how many bonds do I need to add until I have a probability of 95% chance of at least four of them being good. All right? So let's write all of that down right here. So first things first, I need space. So first things first, right here is the probability of at least four. So in other words, the probability that x is greater than or equal to 4. Yes? Right? That's what I'm looking at here. So x follows a binomial distribution, BIN, of n comma p. P is equal to 0.65. And here's the problem. We don't know what n is. And this is the entirety of a quarter problem. In a quarter problem, the unknown value is n. How do you do n again? That's m? I think it's n. The problem right here is n. I want this probability to be 0.95 or higher. But the problem is I don't know how many bonds I should purchase. All right? And the nice thing about salt is because it's interactive, it turns out it takes you like 5 seconds to get to the answer to this problem. Let's go ahead and answer this problem together. Are you ready? So what you do is you switch over to salt. Right? I am going to start n is 4. Remember, I don't know the value of n, right? But I know I need to have at least 4 bonds in my portfolio, yes? I'm putting my probability of a success of 0.65. By the way, this is something that is very common to these kinds of problems. They don't give you P, they give you Q instead, right? Because that will confuse you, right? So you have to read the problem carefully to determine the probability they're giving you is a probability of a success or a probability of a failure, yes? Remember, they said 35% risk of default. That means 65% risk of non-default. Yes? And you want the bonds to be not defaulting. That's why I have right here 0.65, even though the problem said 35%. All right? But it's a very classic trick that they use in these kind of problems. The next thing right here is, am I going to have a left tail or a right tail right here? Going to have a right tail because we want to have at least 4 bonds being good. Yeah. And notice right here that this switches to a greater than to remind you that this is at least. And then I'm going to put the number 4 in here. Like so. So if I have 4 bonds, 65% chance of successful, the probability I get at least 4 of them is only 17, or rather 18%. Nowhere near 95. In other words, we need to put more bonds into the step. Oh, how did I get that? In other words, we need to put more bonds into the stack to get ourselves to a 95% chance. Does that make sense? All right? Questions? Everybody wants to see all of this again, but this time, in English. All right, cool. I'm going to say it again anyways. The quarter is 4. I want to have 4 bonds be successful. That's my quarter. The problem is that if I put exactly 4 bonds into my portfolio, I only have a 17% chance of being successful. So I need to put more than 4 bonds in there. All right? So if I put 5 bonds in there, if I put 5 bonds in there, 5, the probability is now 42%. Look, it jumped by a lot by putting 5 bonds. But that's not enough. So let's put 6 bonds in there. It jumps to 64%. 7 bonds, 80%. 8 bonds, 89%, 9 bonds, 94%. 9 is not enough, right? 10, we have gone past 95%. And so the answer to the question is you need to have 10 bonds in your portfolio. If you have 10 bonds with a 65% successful rate, the probability at least 4 of them will be good is going to be 97%, which is higher than our threshold of 95%. Question 3. And so the answer to the problem is n equals 10. Question 3. Comments, queries, concerns. This kind of question is definitely one that they expected to use technology for, because remember the formula I showed you? You know how long it did take that formula to run it 8 times, like we had to? Yes? They really want you to use the technology to get you to this end. I am paused. Questions? Questions? All right, cool. And so the answer, oh, wrong one. Oh, right. Wrong one. Did I open the wrong one? Where'd it go? I guess I gotta reopen it, huh? And so right here, again, you have to switch the probability to 65%. The number of bonds purchased right here, my quarter. I set up this equation. The probability that X is greater than or equal to 4 must be larger than 95%, because 95% is my cutoff percentage. And then I go to my technology and I look for the value of n that satisfies this inequality. And so I have to keep trying. I try n equals 5. Then I try n equals 6. Well, in this case, they jumped to 9 because they ran out of space. I try n equals 9. Remember, n equals 9 didn't get us to the answer, right? Because the quote, it needs to be 95% or higher. No rounding. You have to just look at the number as is. Yes? And then when you try 10, you get exactly the value we have right here, 97.385, which is above 95%. And so my quota is, I need to have, so to meet my quota of 4, I need to have 10 bonds in my pool of assets. Questions? Like I said, they decided to teach us the hard way. I don't know what's wrong with these people. And, I already showed you guys how to do this in Salt. Keep plugging numbers in until you get to 10. And da 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 da. All right, that is the end of chapter 4. Like I said, our test is on Friday. My online class, the test is on Monday. What will happen on Wednesday? We know we have a in-class assignment. We will work on that in-class assignment on Wednesday. I'll use it as a little bit of a question and answer section and get you guys to practice. Make sure you can use SALT. Make sure you can get answers to these problems. And then we have our test on Friday. All right. Let me take attendance.